Coding and classification. In this video, we are going to see about the coding and classification. What is group technology? In group technology, the parts are identified and grouped into families by classification and coding systems, like for example, bolt and nut, shaft, coupling, bearing. The part classification system is classified according to the following categories: system based on part design attributes, system based on manufacturing attributes, system based on design and manufacturing system attributes. System based on part design attributes. It relates to similarities in geometric features and consists of the following: external and internal shapes and dimensions. Example, bolt external thread that is male, nut internal thread that is female. External thread bolts similar external shape. Screws similar shapes. Nut similar internal shapes. The ratio between length width or length and diameter. Different diameter and length ratios. Dimensional tolerance. Surface finishes. Example, machining. Some of the machined products. Some of the material not removed products. Material type. System based on manufacturing attributes. The manufacturing attributes of a part consist of the following: the primary production processes used, the secondary and finishing processes used, the dimensional tolerance and surface finish, the sequence of operations performed, the tools, dies, fixtures and machinery used, the production quality, the rate of production. System based on both design and manufacturing system attributes. This system contains the best characteristics of both the design and manufacturing attributes. Coding structure. Coding structure is defined as a sequence of symbols that identifies the part design and manufacturing attributes. The symbols in the code can be numerical and alphabetic or combination of the both. The type of coding system structures are hierarchical structure, chain type structure, hybrid structure, hierarchical structure. In this structure, the interpretation of each succeeding symbol depends on the value of the preceding symbols. In this system, there will be a relation between the consecutive numbers. It is also called as monocode. Chain type structure. In this type, the interpretation of each symbol in the sequence is fixed. This is also called as polycode. Hybrid structure. It is the combination of both hierarchical and chain type structure. This method is widely used in industries. Group technology, that is GT. In this video, we are going to see about the group technology, that is GT. Group technology is a manufacturing attitude in which similar parts are identified and gathered together. Similar parts are arranged into part families. Each family possesses similar design and manufacturing characteristics. For example, a plant producing more number of parts may be able to group into a small number of part families. Then each part family has nearly similar processing activities of design and manufacturing. The grouping of machines required for the processing of a part family leads to a better and inexpensive method of manufacturing is known as cellular manufacturing. Part family. A part family is nothing but the collection of parts which are similar in geometric shape and size, or similar steps of manufacturing process are required in the production. The parts may be grouped in group technology by the following: design attributes, manufacturing attributes. Similar prismatic parts requiring similar milling operations, dissimilar parts requiring similar milling operations, that is hole, drilling, surface milling. Identical designed parts requiring completely different manufacturing process, material, plastic and steel. Dissimilar parts requiring similar machining operations, hole drilling. Turning, milling operations, design attributes. In design attributes, the parts are grouped into a family with similar design characteristics and features. The basic idea of design engineers will be about function and performance, and the design should be creative. Mostly in manufacturing industry, a considerable amount of similarities available in the part manufacturing. Creating new parts and introducing new parts are expensive. Therefore, the design of the parts should be modified to a common structure that will reduce the cost considerably. The figure A and B illustrates examples of two parts from the same family. These parts are placed in same family due to its similarity in size and other design features. They have exactly same shape and size, but the production method is different. Even though these parts are grouped with respect to size and shape based on the design attributes. Manufacturing attributes. In manufacturing attributes, the parts are grouped into a family with manufacturing characteristics but different shapes. The figure shows it is observed that the shape and size are different, but the operations are same. Manufacturing part family is really grouping the manufacturing machines into separate work cells. That is, the machines have to be arranged to function. Computer-aided process planning. In this video, we are going to see about the computer-aided process planning, that is CAPP. CAPP is an automatic process planning function by means of computers. CAPP accomplishes the complex task of production planning so that the individual operations and steps involved in production are coordinated perfectly with other systems and are performed efficiently with the help of computers. CAPP requires extensive software and coordinates with CAD or CAM. It is a powerful tool for efficient planning and scheduling the manufacturing operations. CAPP is effective in small volume and more variety of parts. CAPP requires a vast amount of knowledge and experience in manufacturing methods and technology. Approaches to process planning. There are four basic important approaches to perform the task of process planning. They are manual approach, variant approach, generative approach, hybrid approach. Among these, the hybrid approach is an approach to perform the task of process planning which combines both variant and generative type. Each approach is appropriate under certain conditions. Therefore, knowledge of nature, advantages and limitations are important. Variant or retrieval process planning. The flowchart of variant or retrieval approaches to computer-aided process planning. Variant process planning uses the existing process plans and then allow the user to edit the plan for their new parts. The variant CAPP systems are based on GT and parts classification and coding. In this system, a standard process is stored in computer files for each part code number. The process plan for new part is created by identifying and retrieving an existing plan for similar part, and the plan is edited for modification. The standard plans may be based on the current routings or ideal plan is prepared for each family. The basic variant approach to process planning with group technology, that is GT, is go through normal group technology setup procedures. After part families identified, develop a standard process plan for each. When a new plan has been designed, prepare GT code for each part. Use the GT system to look up which part family is the closest match and retrieve the standard plan for that part family. Edit standard plan so that values can match the new design parameters, and add or delete steps are required. The user begins by identifying group technology board for the component for which the process plan is to be determined. A search is made of the part family file to determine if a standard root sheet exists for a given part code. If a file contains a process plan for a part, it is retrieved and displayed for the user. It is an alternative system to variant CAPP. Generative process planners should create a new process plan. This does not imply that the process planner is automatic. A generative CAPP creates process plan using a systematic procedure rather than retrieving and editing plans forms a database. The rules of manufacturing and equipment capabilities are stored in a computer system. Advantages: investment cost is low. Development time is less. It is well suited to medium to low product mixes. It can be rapidly developed by various companies and various parts. It can be interfaced with other SIM operations. One program can be used in different industries. Disadvantages: GT codes cannot be used for a longer period. Planning operations are comparatively slow. More chances of error. GT shop floor layout. In this video, we are going to see about the group technology shop floor layout. GT shop floor layout. The manufacturing of part families is used to assemble machines more efficiently to get a perfect product flow with reduction of time. Every part families, the machines are organized into cells. All cells are prepared to specify in the manufacture of a specific part family. The figure shows the layout of a cellular manufacturing. Traditional manufacturing. In the traditional manufacturing method, the same types of machines are arranged in groups. Then there is a considerable random movement for batch production. The figure shows the layout of the traditional manufacturing. Now, this will create an unnecessary movement of the workpiece. During machining of a given part of a particular operation, the parts repeatedly use the same machine. This results in improper material handling, large in-process inventory, more manufacturing lead time, more loading time, high cost. Routing and dispatching. In this video, we are going to see about the routing and dispatching. Routing and dispatching. Routing. Routing means determination of path or route over which each piece is to travel in being transformed from raw material into finished product. On the routing, there needs to be a list of operations that must be performed at a particular time. Routing of a production order contains a complete description of the item to be manufactured, details of each operation involved in the process, the setup time and the standard time required to complete the work. Advantages of routing. Efficient use of available resources, reduction in manufacturing cost, improvement in quantity and quality of the output, provides a basic for scheduling and loading. Dispatching. The decision of assigning various jobs to different machines is known as dispatching. In other words, dispatching is the routine of setting production activities in motion by releasing the order and instructions as per the route sheet and loading schedule. The following documents are issued to different departments: job order or work order or shop order, material issue order, tool order, move order, final delivery notification. Material requirements planning, that is MRP. In this video, we are going to see about the material requirement planning, that is MRP. Material requirements planning, that is MRP. Material requirements planning is the computational technique that defines when to order raw materials and components for assembly products. The master schedule becomes a direct input to the material requirements planning, that is MRP function, which determines the material needed at each work center location in order to meet the MPS. MRP is the heart of any manufacturing control system. It uses information from the bills of material, item master, master production schedule, inventory, and purchase orders. MPS reads the master schedule to determine what products will be built during the planning period. Bills of material and routing defines the raw materials necessary to produce the product. The instructions and routing, that is S, through the shop floor for making the product. MRP determines the total gross requirement and compares against current inventory and scheduled receipts. If MRP determines that material will not be available when it is required, it can regenerate planned orders for that material. Benefits of MRP: reduce inventory, improve customer service, greater productivity, reduced setup and product change over cost, better machine utilization, increased sales and reduction in sales price, quicker response to changes in demand and master schedule. Manufacturing or Management Resource Planning, that is MRP-II. In this video, we are going to see about the Manufacturing Resource Planning, that is MRP-II. Manufacturing Resource Planning, that is MRP-II. MRP-II is a computer-based system for planning, scheduling and controlling the materials, resources, financial and supporting activities needed to meet the master production schedule. Functions of MRP-II. MRP-II has a variety of functions such as business planning, sales and operational planning, production planning, master scheduling, capacity requirement planning, execution support systems for capacity and material. Features of MRP-II. MRP-II was developed with all the features of MRP-I with some additional key elements in MRP-II to differentiate from MRP-I are response, allocating resources, matching the requirements, software extension programs, popularity, operation planning in units, financial planning in rupees, extension of closed-loop MRP, management planning, customer service, processes planning, business functions. Problems in a company without MRP-II. Delivery dates may not be fulfilled. People heavily rely on hot list and shortage list. People place heavy reliance on paperwork that does not go through the computer system. Inaccuracies in inventory cause production problems. Money gets tied up in unwanted inventory. Expensive rush orders are placed to replenish inventory. Inaccuracies in bill of materials and transaction reporting. Setup of machinery to change to different products is time consuming. At end of the month, there is a huge workload for people to clean the system. Applications of MRP-II. In this video, we are going to see about some of the applications of material resource planning, that is MRP-II are: delivery dates may not be fulfilled, maintenance management, distribution management, customer field service, warranty tracking, marketing support, supply chain management, product data management.